Now we will see the demonstration on virtualization.
OpenStack is a well-known and widely used open source platform for cloud deployments. It consists of an extensive set of software tools that help to deploy and manage cloud services on physical infrastructure. Now, looking at a brief overview of the OpenStack landscape, we have some core services marked in red. These are the compute service, which provide virtualized computing environment for our applications to run on. The applications may run inside virtual machines or containers. The storage services, they provide appropriate storage type to the virtual machines or containers. These include network file system, some block storage and object storage. We have networking services, which provide services such as DNS, load balancing and software-defined networking. Then we have the hardware lifecycle services, which provide provisioning services for accelerators such as GPUs and FPGAs. They also provide bare metal provisioning, which enables infrastructure as a service. The shared services include common services such as an identity service, providing client authentication through an API such as LDAP. We have scheduling service that provides yet another API that can be used to talk to other services. For example, talking to the compute service in order to track resource usage in the cloud or allocate new virtual machines. And image services, which provides bootable images for our virtual machines. We have key management services that provide management of secret data such as passwords or encryption keys and any kind of binary data as well. We also have workload provisioning services, application lifecycle management, and some orchestration services. And finally, we have a front-end service, which provides a dashboard. It's a web app that is used for managing the cloud deployment from a centralized location. Now, all these components are open source, and you can choose which ones you want to have in your cloud deployment. Not only cloud, OpenStack components can also be used at the edge. We can use them to create a virtualized environment for our applications to run at the edge. However, edge is a more restrictive environment, and we might not always require all these services running at the edge. For example, we have some sample configurations here. We have the compute starter kit, which basically consists of just 5 of these OpenStack components, which are the Nova service, the Glance service, Keystone service, networking, and then the placement service. These are the most basic services that you would require to have an up and running cloud or edge deployment that you can host your applications on or provide virtual machines to your customers. We have other sample configuration here. For example, the web application. It has 10 of these services, including a storage service, a database service, and also the orchestration service. Now, since all of these components are open source, other organizations have created their own customized version of the stack, one of which is MicroStack by Canonical. MicroStack is an OpenStack designed for small-scale production environments. Again, the reasoning here is that OpenStack has a lot of components by default, and which might be not required in particular use cases. They say that the core components which are required for most of the use cases are, in fact, compute, network, and storage. With these components, one can start a minimal cloud or edge deployment. So MicroStack comes with all these components listed here. All these are OpenStack components packed into a single package that is called the MicroStack. Now let us look at the architecture of MicroStack. MicroStack can be deployed as single node or it can span across multiple nodes. In a single node deployment, what happens is there is one server or a physical machine here, and you install all these packages, right? The OpenStack services, you have a Sunbeam Snap store where you'll get these services from, and micro Kubernetes, this micro K8s and this Juju client. This will help you get this software and install it on your edge or your this virtualized environment when you demand it. So in that case, there are multiple roles, but in a single node deployment, the node will assume all roles, which are basically control, compute, and storage. So that happens in a single node deployment. But when we come to multi-node, what happens is that all the nodes start off as a single node deployment, and then we can add additional nodes to the deployment and expand the capacity and resilience. So in that case, what happens is there are multiple servers, each are running this stack, OpenStack or the microstack, and then you can assign them roles. So one would be a control role, the other one will have compute role, maybe third one will have storage role. We shall now look at a scenario where we shall create a topology like this. We have two nodes, a red node and a blue node. These are the physical nodes, and we want to create an edge infrastructure or deploy the edge here using these two nodes. The nodes are connected through two networks. As you see here, one is the internal network with the network address starting from 12. The internal network is used for administrative purposes and providing connectivity between these nodes. The other network is this external network starting with IP address 10. This external network is supposed to provide connectivity to our nodes or our deployment to the external cloud or the internet. So there will be one router here which will route all the traffic to and from the internet to our edge deployment. So with that, let's move on to the demonstration. We shall start by installing the microstack on both of our physical nodes. I shall log in into each of these nodes and install the required packages there. Now I am logged into both of these nodes. The top one is the red node and the bottom one is the blue one. Now we need to install the microstack package. We can install it from the Snap Store. We can use this command to install microstack from the Snap Store from the Edge channel. I already have the microstack package downloaded on my node here. As you can see, I have the assert file and the snap file. I shall use these packages to install microstack. Microstack has been installed on the red node. Let us install the same on the blue node as well. We already have the same package on the blue node as well. MicroStack is installed on the red one. Now we shall initiate the MicroStack cloud or the edge using the MicroStack init command. This will initialize a cluster. We have to configure the cluster, say yes. Now we have to assign the role to this node. We shall assign one of the roles. So let us assign control role to the red node. We should provide an IP address. Now we shall use the 10 network here. Now this is being set up as a control node. This will take some time, so we shall wait for the process to complete. We can access the dashboard here using the following IP address. It's 10.20.20.1. We shall use a browser to access the web app, that is the dashboard for our deployment. We have landed on the login page. Use the admin username here. To obtain the admin password, use the following command. Use this command to obtain the password. The password is displayed here. Copy this password and use it to log in. We are now on the home page. This shows an overview of our compute volume and network, that is the resource usage. We can see the API. These are the services that were installed. We have compute, identity, image, network, placement, and storage services. These have their own APIs running on the control node. We can check the instances. Currently no virtual machines running. We can launch instances from images. The CircOS images is already present here by default. We could launch it from here. So let us launch an image. But before that, we shall check out the network here. This is the network topology. We have an external network. The external network is being connected to the test network using a test router. As you can see, it connects to two of these networks. We have a test network here, that is an internal network. Let us check the topology here. You see that this is our cloud deployment. It has its own subnet. Now this router is our test router that is connecting our deployment to the external network, which is this one. So right now there are no virtual machines. We can create virtual machines here and then assign them IP addresses and connect them to networks. So let us create a new instance. We shall name it as test VM. The volume should be no. We shall not provide any storage to this one. Select the image. Select one of the flavors. These are pre-built flavors here. We can select the tiny one. select a network that it needs to connect. We shall select the test network. And with that, we are ready. Let us launch the instance. The instance is being launched. Let us check here on the instances section. It has been created and the status is showing as active. We can check what's going on with this test VM. We can look at the console. We see that the VM is booting up. We shall wait for the VM to boot up. Meanwhile, we can check our network and we shall assign an IP address. That would be a floating IP address. So create a new floating IP address here for our test VM. There is an IP address. We shall associate this IP address with our test VM. Floating IP has been assigned to our test VM. Now we can see in our topology that the new virtual machine is created. It is connected to the test network as we had specified. It has its own IP address and it is also available from the external network because we have assigned a floating IP to it as well. So now let us go back to our instances and launch another virtual machine. Let's call it test VM2. I shall create a similar VM that I had created earlier. Attach it to the same test network and launch the instance. Test VM2 is also being launched here. It is being assigned an IP address on the test network already. So we shall later on assign or associate a floating IP with this as well. It is active now. Let us see what's going on with this VM. The VM is currently booting up. Now looking at our network topology again, right, we see that the other VM is also now showing up here. It is up and running. It is connected to our test network as well. It has its IP address assigned to it as well. This means that these two VMs can now talk to each other via our internal network. That is our edge or the cloud deployment. Now let us check our compute overview. We see the resource utilization. We also see the floating IPs. So let us assign a new floating IP to our second test VM. click on allocate IP. This would be for the second VM. I will associate this IP address to test VM2. The IP has been associated. Now let us try to SSH into one of these VMs. I will try to SSH into the first VM here. I shall keep one shell open for our red node, and I shall SSH into the first VM from the red node. We are now into the virtual machine. Let us check the uname. It is the CircOS. We can check the IP address here. We see that there is one link which has been assigned this IP address on the test network. Let us try to ping the other virtual machine which is also connected to the test network using this IP address. So we should be able to talk to the other one. Yes, it is pinging. So that means both of them have connectivity. They are connected through the test network. So now we have this kind of topology here. We have created two simple virtual machines in our own cloud deployment. We have created a network that is providing connectivity among our virtual machines. They have been also assigned floating IP addresses so that they can be accessed. So let us now stop this ping and exit out from our VM. Now for the blue node, we haven't really set it up. We can see under the admin section all the hypervisors that are available or the compute services. We want to look at the compute hosts. We see that only one compute host is available, that is our red node. And we would like to add the blue node as a compute. So let us also initiate our microstack here, but this time we will assign it the compute role instead of a controller. Now we need to provide the add compute. So this, you have to run this command on the control node and it will return a connection string that we need to provide to add this blue node as a compute node. So this is the string that is generated. It is valid for 20 minutes. We can simply use this string here. So now the blue node is being set up as a compute node. Once it is up, it will join the cluster. The blue node has been initialized and it has joined the cluster. So let us check that. Now we see the host node, that is our blue node, is now joined the compute host, joined as a compute host. So it will be used to provide compute to our virtual machines. So now we have two nodes acting as compute and control nodes. We have realized this architecture or the deployment with our two nodes acting as the physical nodes, and we creating virtual machines on top of that and virtual networks. So this would be our virtualized environment, our own cloud or the edge deployment here that is built on top of this physical infrastructure. We shall start with an introduction to KVM. We shall see how to enable KVM, that is to install KVM and related components. We shall see how to create virtualized environments that will have virtual networks, virtual storage devices, and virtual machines. Finally, we shall see how to connect the virtual machines through a virtual network. KVM or kernel-based virtual machine is an open source full virtualization platform for Linux on x86 hardware. The hardware must support the virtualization extensions. Those are AMD V and Intel VT. KVM is a type 1 hypervisor that is built into the Linux kernel. It is available as a set of loadable kernel modules. Apart from KVM modules, we require two additional components. Those are QEMU and libvirt. QEMU is short for Quick Emulator. It's a hardware emulator or processor emulator that can emulate various hardware devices. We shall use QEMU alongside with KVM in a special mode that is called the hypervisor support mode. In that mode, QEMU acts as a emulator for various devices that the virtual machine is going to use. Virtual machine itself will run under KVM, and QEMU will provide the emulated hardware support for this machine. The other component is libvirt, which is a library. It provides an API, a daemon, and a CLI tool. Libvirt is also used by other tools such as the Virtual Machine Manager, which is a graphical user interface that is used to manage these virtual machines and the hypervisors. Now, QEMU and KVM can be installed only on a Linux system, and we require the following packages as listed here. After you install these packages, make sure to reboot the system. These packages listed here are for a Debian based package, APT package manager, but it might differ for some other distribution. With that, we shall move on to the demonstration. As you can see, I'm using Ubuntu 22.04, the kernel version 6.5. This is the host machine. Now the host layer represents the hardware that is going to be virtualized. We need to check whether the host machine supports the virtualization extensions. As you can see, the AMD V virtualization extension is present on the system. So now we shall go ahead and install the required packages. These are the required packages. Let us install them using the APT package manager. The packages are being downloaded and they will be installed shortly. The installation process is completed. This means all the packages are installed, and at this point we would require to reboot the host machine. So I shall reboot the host machine now, and then we shall move on to the next part. The system has rebooted, and now we are ready to create a virtualized environment. We shall use the Virt Manager for that purpose. To launch Virt Manager, use the command virt-manager. This shows up the Virtual Machine Manager window. Virtual Machine Manager or Virt Manager is a graphical tool that is based on libvirt. It is used to manage hypervisors and virtual machines. We can manage multiple hypervisors using Virtual Machine Manager and even connect to remote hypervisors over SSH. We can see that the QEMU KVM hypervisor that we had installed earlier is already connected and showing up on the list. To manage the KVM, right-click on it and go for details. This shows an overview of hypervisor's resource consumption, which is currently 0 as nothing is running on it. We can see 2 additional tabs, virtual networks and storage. Under the virtual network section, we see that a default network is already present. It is currently active and uses VIR BR0 device on the host. It has a NAT type of forwarding. It also has its own DHCP server, which is assigned to IP addresses within this range. We also have a network ID. This will assign an IP address to the bridge itself. Now we shall not use this network. Instead, we shall create a new network that will be an isolated network. I'm going to stop this network. Click on the Stop Network button. The network has become inactive. Now I shall create a new isolated network. It will not have any NAT forwarding or a DHCP server. This virtual network shall allow the virtual machines to talk to each other and to the host, but not to any outside network such as the internet. We shall add a new isolated network. To create a new network, click on the Add Network button. Select a name for the network. We shall call it IntNet for internal network. Select the mode as isolated. Under the IPv4 configuration, disable the DHCP server because we will assign the IP addresses manually. Also disable the IPv4, that is, we do not want to have an IPv4 for the bridge. Keep the rest of the configurations as they are and then click on Finish. We see a new IntNet network has been created. It is active and is using a device VIR BR1, that is Virtual Bridge 1 on the host. Now coming to the storage section, we can see the available storage pools on the left. A default pool has been created at this location on the host file system. The volumes inside this pool will be listed here. It is currently empty as there are no volumes inside the pool. Volumes can be attached as virtual storage devices on the virtual machines. They can act as, for example, virtual hard disks, as local storage device for VMs, or as a bootable CD-ROM drives that can be used to install operating systems on the VMs. Now I have already downloaded some operating system images. As you can see, I have a few Ubuntu images and a Fedora and a Debian image. We'll have to add these images to our pool. So what I'm going to do is instead add a new pool from this file system location. So copy this location on the file system. Let's copy that path and we'll add this as a new pool on the Virtual Machine Manager. So click on the Add Pool button. Provide a name for this pool. We shall call it guest. Then provide the target path which we had copied, paste it here, and then click on Finish. The new pool has been added. You can see all the ISO, the operating system images are listing up here. we shall use these images, we shall attach them to virtual machines, and then we could use them to boot or install the operating system. Now we could add additional volumes, like for example if we wanted to add a hard drive. So create on a new volume, provide a name for this volume, let's call it HDD for hard disk drive. Keep the format as it is and select the capacity as 5 GB. Now this will be a local hard drive for the virtual machine. Click on finish. The new hard drive is showing up inside the volumes. We shall attach it as a local hard drive on the virtual machine. Now there are other ways to create virtual storage devices, such as from our host machine we could use tools such as the genome disk utility. So use the command genome disk. It will launch a disk management utility. Click on the applications menu and click on new disk image. We have to provide a name and size. I'm going to call this new disk as the external disk. Let's name it as external. We shall provide 2 GB of storage to this disk, and we shall save it in the same location where our other operating system images were, so that it shows up in the pool. Click on attach new image. So new image or a new disk has been created. It is currently empty. There is no file system. We need to format this partition. So click on the format partition. We shall provide a volume name. Let's call it external. Now select the type of file system. We shall go with FAT file system so that it is compatible with devices. Click on format. Now we can see the external device has been formatted and it is also mounted on our host file system. So we can go to our host and check the file system. Here we can see on the left a new drive. External drive is showing up. It is currently empty. Now we can create files here. So let us create a file here on the external drive. I'm going to CD into that location and then create a new text file. So I'll create this new text file called hello.txt with some text in it. So the new file has been created on the external drive. You can see it is appearing on the drive. We shall use this drive to share files between the virtual machines. So click on refresh. Refresh the volume list. We see the external drive is now showing up on the volumes. One thing which I noticed is that I have not provided a correct extension to this file name for the external drive. So we will correct that. So let's go to that location, the location of a pool. This is the external drive. We'll rename it to .img. Now that is the correct extension. We can refresh the volume list. We see the changes are now showing up. So now the storage is ready. We have our operating system images, hard drives. We have the virtual networks as well. So now we shall move on to the next part where we shall create virtual machines. To create a new virtual machine, click on this Create New Virtual Machine button, or otherwise go to File and click on New Virtual Machine. Now we have to follow a few steps here. Select Local Install Media. We have the ISO images for our operating systems. We need to select one ISO image here. So browse for it under the guest pool. We have to select one operating system here. I shall go with Ubuntu 16. Select this ISO image and click on Choose Volume. The operating system has been detected correctly as Ubuntu 16. Now click on Forward. We have to assign memory and CPU. I'm going to assign 512 MB of RAM and one virtual CPU to this virtual machine. We could change it later as well. Click on forward. Now we could attach a hard drive here. We had created a hard drive earlier. We will select that hard drive. Under the guest pool, we shall select HDD image, that is the 5 GB drive. Click on choose volume. Now click on forward. The virtual machine is almost ready. We could rename it if we wanted to. Select this customize configuration, and under the network selection, select the internet network, that is our isolated network. Click on finish. The virtual machine is almost ready. We could start installing the operating system here by clicking this begin installation, but we shall check out the other options here quickly. We see an overview of a virtual machine. Then we have the operating system information, the hardware information, CPUs, memory. We could change it from here if we wanted to. We have boot options. We have booting from hard disk, CD-ROM or network, but we will enable this boot menu so that we can select it from the VM. Click on apply. We see the external storage devices, that is our HDD, the 5 GB hard drive, and then we have an IDE CD-ROM that contains the operating system image. You can see under the advanced options that it is mounted as a read-only. Then we have our NIC, that is the network card. We have already selected it as the internet. It has its own MAC address and the link state is active. There are other options and information about the VM. We shall not change these, but we can add a hardware if we wanted to. Click this add hardware button. There are a lot of options. For example, we could add additional NICs from this network section here. We could also add, for example, storage devices. So we had created an external drive earlier. We shall attach that drive here. So click on manage, and from the guest pool, select that external image file. Click on choose volume. Now this image will be mounted on the virtual machine. We can select which device type it should be mounted as. There are a few options. We will select the disk device. Under the advanced option, we shall make it read-only and shareable. Shareable so that multiple virtual machine can share them and it can be mounted on them simultaneously. Click on finish. Now we are ready. We see that this external drive or the external image file has been added as a device on the virtual machine. It is readable, read-only and shareable. Now click on begin installation. Press escape for the boot menu. Now we have to select the appropriate device to boot from. We can see the first option. It says Ubuntu Server 16.4, that is our operating system image. So select one from here. The installation of our operating system has begun. We shall go through this installation quickly. I'll be selecting all the default options. So the operating system has finished installing. It's asking us to remove the CD-ROM. We can remove that CD-ROM, go to the hardware details, select that IDE CD-ROM, and then click on the cross button. It will remove that ISO image from that drive. Go back to our virtual machine, press on continue. It will now reboot the system. The system is now booting up. It is a server edition, so it won't have any GUI. There is only command line interface. It's asking us for a login. Let us log in into the machine. We are now logged in into the machine. As you can see, it's Ubuntu 16 server. Now we can check the IP address. We see two devices here on the virtual machine. One is a loopback, and the second one is the ENS3. This ENS3 is the same network card that we added to the machine that it will use to connect to that virtual internet network. So all we need to do here is now assign an IP address to this interface and bring it up, because currently you see the state is down here. Use the IPA command or IP address command. So IPA add, and then we need to specify the IP that we want to assign to this machine. So 192.168, then 0.100. Let's assign 100 here, and we will use 24, that is 24 bits network ID. Then specify the device name as ENS3. This will add an IP address. We can check that. We see new IP address has been assigned to that interface, but it is still down. We need to bring it up. So IP link set, IPL set, the device name, and then up. So the device is now up. It has an IP address. So now we also need to assign an IP address to the bridge. We don't really need it, but we shall assign it. The VIR-BR1 is the interface name. Now let us assign an IP address to this VIR-BR1. So I'll use the IP command again. Add 192.168.0.1. Let us assign 1. And then the device name, of course, it's VIR-BR1. So I forgot the net mask, so I need to provide 24-bit network ID, so /24. So IP address has been added. Let us see. The IP address has been added to that VIR-BR1, and it is up already. So that means now that our virtual machine and the bridge should be able to talk to each other. We can check in this diagram that new IP address has been assigned to our bridge. Now, since it has been assigned an IP address, we should be able to ping the bridge from our virtual machine. Let us try to do that. We'll ping this bridge. Yes, the bridge is being pinged by the virtual machine. We can also try to ping the virtual machine from our bridge device that is on our host. So ping that virtual machine .100. The bridge is also able to ping the virtual machines. The virtual machine, that means both of them are connected through the virtual bridge. Now we'll try to bring down that virtual bridge. We can bring it down using the simple IP link set command. The bridge is now down. We can see the ping has stopped. So we are not able to ping the virtual machine from here as well. So now let us try to bring that bridge up again. We'll see the command. It's still not up. We'll give it some time. It's up now. The ping has resumed. We'll check the diagram again. It is now showing as up. The ping has resumed on the bridge on the host, and it has resumed on the virtual machine as well. Now we have created one machine and connected it to the bridge. Now we would like to add another machine. So for that, what we can do is create a machine just like we had created this one. We could go to file and then add a new machine, click there, follow the steps again. But instead what we will do is create a clone of this existing machine. So we can click this clone button, but right now it's not active because the machine is running. We need to turn off the machine and then we would be able to create a clone. So we can shut down. Let us issue the power off command. The machine is shut off now. Close this window and then now we can clone it. So right click and click on clone. Now I need to provide a name to this clone. Let it be what it is right now. And on the hard disk options, we see that there are many devices here. The one is the hard disk, that is a local hard disk. We would want to create a clone of this hard disk so that the clone doesn't share the operating system. But we will not clone the other external device. We want this device to be shared among the clone and the base machine. So select only the local hard drive and then click on clone. A new machine has been created, that is a clone of our original machine. So let us power both of these. Let us power them on. So both of them are running. So right click and select open. Now we shall also power on the clone. We have already powered it on, so open it. Check the IP address here. We see the same two devices. Even though these two are clone of each other, you see the MAC addresses are still different for the ENS3 device. The MAC addresses won't get cloned. So now to connect both of these to our virtual bridge, we shall use the same command. We'll start with the original machine, the base machine. So again, use the IPA command, IPA add, but we need to select the appropriate IP address range. Right, so now the device is up and IP address has been assigned. This means that this virtual machine is now connected to our bridge. We're trying to ping the bridge. Yes, the machine is able to ping the bridge. Now we shall do the same thing on our other virtual machine, that is the clone. So use the IPA command again. Right, so now we have an IP address assigned to this interface. Let's try to ping the bridge first. The VM is able to ping the bridge. Now we can try to ping the other virtual machine. Since they are now both connected through the virtual bridge one, they should be able to talk to each other. Let us check that by pinging them. So this means that now both our virtual machines are connected to each other and to the host as well. So we can now try to bring that vir br down. So we need a sudo access for this command. So now the bridge should be down. Yes, now we see that the bridge is down here. So the ping should have stopped here. As we can see, the ping has stopped between both these machines. So now let us try to bring that bridge up again. So we can use again the same command. Instead of down, we shall use up. Yes, so now it is up. So now the ping has also resumed. So now that we have connected these machines through a virtual network, the other thing remaining is to attach the virtual storage, the external drive that we had created. Now we need to attach this virtual drive. It is already attached. All we need to do is mount that device that is on the virtual machine. So for that, we can use the mount command. First, we shall exit out from these terminals, because now that the machines are connected through the network, we can SSH into them from the host machine. So let us exit from here, close this terminals. So now we are logged into the virtual machine through our host terminal. We see the IP address here is 102. here it is 101. So now we would want to attach or mount that device, external device, onto our host file system inside the virtual machine. Now I've created this directory ext so that I would be able to mount that external drive on this ext folder. So let us first check this fdisks. Okay, we see that VDB is our 2 GB drive here. Now let us mount that VDB onto the ext folder that we had just created. So for that, use the mount command like so. Specify the file system, that is FAT. So vfat for that. Then your device, that is VDB. And then the directory on which you would like to mount. So it is mounted as a read-only device. Now let us cd into that directory. We see that hello.txt file that we had created is now appearing inside the virtual machine. So the VM has access to this machine, to this file, and it can read this file as well. So this way we have mounted an external drive on the virtual machine as a read-only drive. It is also shareable. That means we can mount it on this virtual machine as well at the same time. So let us try to mount it here as well. So we use the same commands again. So first I need to create the directory. Inside the ext directory, the hello.txt file is there. We shall read this file, and we are able to read this file. So now that external drive is being shared by both of these virtual machines at the same time. So now let us exit out of these virtual machines and conclude our demo. In this demo, what we had done is created a virtualized environment where we have a virtual network like this. We had created so many virtual storage devices. We had added pools, and then we created virtual machines. We cloned a virtual machine to create two virtual machines. We connected both of them through the virtual bridge. And with that, I will conclude the demonstration. Thank you.